All right, guys. So make sure you have your name, ID, your name, first name, last name, and your KDIC name in your Zoom name. And we'll get started in a few minutes. All right, so let's go ahead and get started. So in this review, I'll be using test review, the homework, and one of the problems in the notes. So if you want to go ahead and get that stuff ready to go over, that doesn't be easy. So we're going to start with the test review because I think most of the stuff I'm using is from the test review. And for all y'all joining, please remember to put your first name, last name, and the KDIC number in your name, please. So go ahead and change. Make sure you have your KDIC number in your name. So we're going to start with a test review on number 2. And on number 2, what we need to do is we need to simplify this expression. So I have 4 plus the square root of 7 all over 8 plus 3 root 7. And I want to simplify it, and I'm going to simplify this by rationalizing this whole expression. So I don't want a root in the bottom. I'm going to multiply top and bottom by its conjugate, because when you multiply it by the conjugate, you get rid of the square root, or it turns into the form a squared minus b squared. When you multiply 2 square root conjugates, it becomes in the form a squared minus b squared, so it gets rid of that square root. So what you end up getting, I'm actually just on the bottom. We get 4 times 8, that's 32. 4 times negative 3 root 7 is negative 12 root 7. Root 7 times 8 is a positive 8 root 7. Root 7 times negative 3 root 7 is going to give you negative 3 times 7, since root 7 times root 7 is 7. And on the bottom, it goes into the form a squared minus b squared. So 64 minus 3 root 7 times 3 root 7, which will be 9 times 7, which is 63. So when I simplify this down, this negative 37 becomes negative 21. So I have 32 and negative 21. That's going to give me 11. Negative 12 root 7 and positive 8 root 7 is a negative 4 root 7. And on the bottom, 64 minus 63 is just going to be 1. So we're left with 11 minus 4 root 7. And that gives us answer choice C. Any questions about that? All right, let's keep going. Now we're on number 3 in the test review. And for number 3 in the test review, we have this expression right here, and we're going to simplify it down. Tanish, go ahead.
So for number 2 on the test review, for the multiplying the bottom number, so like when you multiply by the conjugate, is there a way of predicting what it's going to be without multiplying it? Like I know there's a formula. I used to do it like incorrectly, so I just FOILed the bottom as well. But apparently there's like a faster way.
The faster way is that this is the factored form of a perfect square of a difference of squares. A squared minus b squared, that's a minus b, a plus b. So when you have something in the form a plus b, a minus b, I know this is going to factor out into a squared minus b squared, where a is 8, so 8 squared is the 64, then 3 root 7 is your b value, so 3 root 7 squared gives you 3 times 3, which is 9, and root 7 times root 7, which is 7, or 9 times 7, which is 63.
Okay, got it. Thank you.
Yeah, and that's why later on in this review, we're going to do something where we rationalize something with a cube root on the bottom, and that's why it's what you multiply with that one's going to be a little different, and we'll
All
also
right.
explain that a bit when we get there.
Thank you.
No problem. Any other questions about this problem? Ready to keep going? All right, let's keep going. On to number 3 in the test review. So number 3 in the test review, I have this expression right here, and I want to simplify it. So the first thing I'm going to do for this one is I'm going to combine the x's if I can. Or actually, I'll reduce the 32 over 4. So I can reduce that to get 8x to the 3 over 2 all over x to the 9 over 5. That's all to the negative 5 over 3. And then from there, what I can do is I can just get rid of this negative exponent by flipping what's inside of here to get x to the 9 over 5 all over 8, which is the same thing as 2 cubed x to the 3 over 2 all to the power of 5 over 3 now. So anytime you have a real number, my advice is to always put it into its prime factorization, just because it makes it a little easier to work with, especially when it comes to exponents. So anytime I have like an 8 or something like that, I'll change it to 2 or 3 or whatever its prime factorization is. It just makes it a little easier to work with, especially with exponents. So from here, I'll take this 5 over 3 and distribute this out to everything that has exponents, and that includes real numbers. Harshita, go ahead.
Why did we like flip them again?
Because you see this negative right here?
Uh-huh.
That's a negative exponent. So
okay.
Yeah, so to get rid of that negative, you have to flip the base. So
okay.
Yeah, remember, because like a to the negative 1, that's the same as 1 over a to the first power. You get rid of that negative by flipping the base.
All right, thank you.
No problem. All right, so I'm going to distribute this 5 over 3 to everything that has an exponent. So what I end up getting is x to the 9 over 5 multiplied with 5 over 3 all over 2 to the 3 over 1 power, which is just 3, times 5 over 3, then x to the 3 over 2 times that 5 over 3 again. And then I'm going to simplify these exponents. So on the top, these cancel out, leaving me with 3 on the top, and these just completely cancel out. And that leaves me with x to the 3rd power on the top. And then for the 2 to the 3rd power, when you raise that to the 5/3 power, these 3's cancel out, and I'm just left with 2 to the 5th power. And then for the x to the 3 over 2 times 5/3, these cancel out, and I'm really just left with x to the 5 over 2. But I have 2 things that have bases of x's, so I can rework this part and can combine them. When I say rework, I mean really just we can combine these x's. So I can rewrite x to the 3rd as x to the 9 over 3, or 9 over 3, 6 over 2. Since 6 divided by 2 is 3, And that gives it so that the base, or it has the same denominator, the exponent has the same denominator as the x in the bottom. So 2 to the 5th power, that's what, 2, 4, 8, 16, 32. X to the 5 over 2. I can combine these x's now because it's just going to be a subtraction problem. Garish, go ahead.
Or it was just a question later for later.
Okay. Let me finish this problem then, I'll come back to you, all right? So these cancel out, so I can rewrite that as x to the 6 over 2 minus 5 over 2 all over 32. And that's just going to be x to the 1/2 over 32. And you can write it this way, or the square to x over 32. They're both fine. They both say the exact same thing. One just an exponential form, one is exponent form, the other one is in a radical. So that gives us answer choice B. And Garish, what was your question?
Yeah, can you just go to the first slide, Mr. Aziz? I just want to take a screenshot of it.
Yeah, sure. So let me leave this up for a quick second.
Yeah.
Else? Everyone okay with this problem? Any question? Good. All right, so here's the first slide. Garish, you can take a screenshot. Got it?
Sorry, it's just stuck on the third question. Yeah, I got it.
Got it?
Thank you.
No problem. Number 5 on the test review. So we're going to simplify this expression right here. So to simplify this expression on number 5, I'm going to rewrite this as an exponent or into exponents so I can kind of combine them. And I'll show you kind of an easier way to go about it. So I can rewrite this as r to the 1/2 and t to the -1 to the 1/2. And then for the 6th root part, I can rewrite this as r to the -5 over 6 and 2 to the 4/6. So I can rewrite it this way. And then from there, I have everything being multiplied. Like I have 2 r's being multiplied together and 2 t's being multiplied together. So I can rewrite this as r to the 1/2 plus -5 over 6, or really just -5 over 6. And then with the t's, I can rewrite this as t to the -1/2 plus 4 over 6. So I'm really just combining them together. So this r to the 1/2 is the same thing as 3 over 6 minus 5 over 6. This t to the -1/2 is the same as -3 over 6 plus 4 over 6. So I'm changing them so I can actually combine the fractions. And I end up getting r to the -2/6 right here, which is -1/2 or -1/3, sorry. And then -3/6 plus 4/6 is just a positive 1/6. And actually, I'm going to sorry about this. I'm actually rewrite this -1/3 to -2/6. I'm going to leave it as a base of 6. And the reason I'm doing that is so everything has the same root. I don't want to have different radicals happening in one answer choice. I only want to have one radical. So I can rewrite this now as t to the 1/6 all over r to the 2/6, which ends up becoming the 6th root of t all over r squared. And this is the answer that we have here, and that's going to be answer A. But in all honesty, this isn't how you want to leave it, because this is the same thing as saying you have the 6th root of t all over the 6th root of r squared. And remember, we don't want to have any radicals in the bottom. So even though the answer choice doesn't say it, we're going to actually solve it out completely, and we're going to rationalize it. And because this is the same thing as saying, sorry, not r, but t to the 1/6 all over r to the 2/6, I can multiply top and bottom by r to the 4/6, not 4/4, but 4/6. And the reason I'm doing that is because when you multiply these two r's together, you get r to the 6 over 6, or really just r. And on the top, you get, just t to the 1/6 times r to the 4/6. They have the same radical, so I can rewrite this as the 6th root of t times r to the 4th all over r. And that should have been the real answer. I don't think that has an answer choice, though, does it? It does not. But that should have been, that's the rationalized form that we would want you to put it in on the test. Any questions about that? Are we good? Great. All right, so I said there's gonna be another way we could have done this. Makes it a little easier. It's the way I personally like to do it. And the way I would have done it is that since this square root is a power of 2, I can just multiply every exponent and root by 3 here on this first one to put it all underneath one root. So I can rewrite the square root of RT to negative 1 to the 6th root of R cubed T to negative 3 times the 6th root of R to negative 5 T to the 4th. Because these are simplified, right? It's the exact same thing. R to the 3 over 6 is the same as R to the 1/2. And T to negative 3 over 6 is negative T to negative 1/2 is what we have in the beginning as well. So these are pretty much the same things. They're equal to each other. So because they have the same root, I can just combine them into one big root and say, well, now I have R to the 3rd, R to the negative 5, T to the negative 3, and T to the 4. And then I can just add the exponents, and I have, well, the 6th root of R to the negative 2 and T to the negative 1, or sorry, T to the positive 1, sorry, which becomes the 6th root of T all over R squared, which is what we got in the beginning. I'm not going to rationalize it again because we already saw how we can do that. So that's like a little quicker way you can do it. You can go about it, and that's how I would do it. But they're both the exact same thing. You get the same answer either way, and both ways give you A. Any questions about either of those ways I did it? Are you okay? You had to put it in the first form. What do you mean by the first form? Do you mean like the answer choice A? Do you have to put it in that form? The other one, do you mean this form right here? Yeah, that's the one we would want you to put it in. I think it was just a mistake on us that we accidentally gave you an answer choice that wasn't fully rationalized here. But yeah, we want it in this form right here where it's completely rationalized in this middle box of answer. That's how we want the answer. Good question though. All right, if there's no other questions here, we'll keep on going. Now we're on number 6 on the test review. So I have 13 plus 196W minus 3 to the 4th third equals 22. And what I want to do here is I want to solve this out for W and then plug those W's into here. All right. So I have 13 plus 1 over 9, 6W minus 3 to the 4 thirds equals 22. Look at the previous question for a second after you're done with number 6 and get a screenshot. Yeah, so once I'm done with this problem, I'll go back to the previous problem so you can take a screenshot. All right. So I'm going to solve this for W. So what I'm going to do is isolate this, the W that we have here by subtracting 13. I get 1/9, 6W minus 3 to the 4 thirds. And that's going to give me what, 9. Then I can multiply both sides by 9. So I can get rid of this 1/9 and move it over to the other side. So I have 6W minus 3 to the 4 thirds. And that equals, that's 81, right? 9 times 9 is 81. But I'm going to rewrite this as 3 to the 4th. 3 to the 4th is also 81. And like I said before, anytime you're dealing with exponents, my rule of thumb is always put it into your prime factor, put your real numbers into your prime factorization. So when you deal with exponents, it kind of cancels stuff out a lot easier. And you'll see that it works over here too, because I need to raise both sides to the 3/4 power. Because when I do, it cancels out the 4 thirds. It's kind of like keeping the W inside the parentheses. I can get rid of it that way. So I can get on the left side, 6W minus 3. And on the right side, I have a plus minus of 3 to the 4 times 3 over 4, right? That's the 3 over 4 here. We distribute it in. We have 4 times 3/4. The 4's cancel out, and I have 6W minus 3 equals plus minus 3 to the 3rd power. And we have this plus minus here because we are taking an even root on the problem, so you have to put a plus minus. Garish, go ahead.
So, Mr. Aziz, do you have to have the plus minus when it's an even root, like when it's an even root, or like if it's a originally even root and then it becomes another even root, do we have to keep the plus minus, or do we only put it if it becomes odd? If it becomes odd power?
You put a plus minus anytime you're taking an even root of a variable. Because like when we take the square root, remember we had different problems where we're solving for x and we take square roots on both sides and we put a plus or minus. Like when we solve quadratics,
Yeah.
you have a plus minus, right?
Yeah.
Yeah, it's the same thing, and that happens with all even roots, just because of the property of how even roots work.
Yeah. Okay.
Make sense?
Yeah.
All right. So I have 6w minus 3 equals plus minus 3 to the third, or I can rewrite this as 6w minus, or plus 3, sorry. We can add that 3 over. I have 3 plus or minus 27. So I can split it up from here and say I have 6w equals 3 plus 27, which is 30, or 6w equals 3 minus 27, which is negative 24. So we get w equals 5, or w equals negative 4. Garish, do you still have a question, or are you good? Okay, perfect. So this is what I have. I have w equals 5, or w equals negative 4. So typically you have to check this. I'm not going to waste time checking it because I have a bunch of problems I want to go over. Oops, should I do that? But typically you'd want to check this problem, make sure these both work. I'll leave that for you guys to do on your own. But we're going to go ahead and plug these back in. Tanish, go ahead.
So when you plug the variables back in to check for them, like into the original equation, and if you get something like 28 equals 28, does that mean it works?
Yeah, you're plugging it in, you're making sure the equality makes sense. So you plug in real numbers, you want to make sure that the equality sign makes sense. So that's why, yeah, so you get 28 equals 28, that would work. But if you get something like 28 equals negative 28, that means that W value didn't work. Doesn't work.
Okay, and one other thing. If you have a variable on both sides and then you take a even square root, then what do you do with the plus minuses?
You still have plus minuses there.
Okay, thank you.
All right. So now I have my W's. You should double check them, but I'll leave that for you guys to do on your own. They do work. So I'm going to plug them back into 3W plus 21. So I have the square root of 3W plus 21. And I want to know, what do I get when I plug in W equals 5 into here and W equals negative 4? So when W is 5, I get the square root of 3 times 5, which is 15 plus 21, which is the square root of 36, or just 6. When W is negative 4, I have the square root of negative 4 times 3, which is negative 12, plus 21, which is the square root of 9, which is just 3. So even though my W's are different, I'm not asking, the question isn't asking for W specifically, it's asking what do you get when you plug in your W values that you get into this equation. So in this case, it's 6 and 3, or 3 and 6, however you want to say it, which is 2 and 5, so it's... Any questions about this problem? All right, Malachi, we're gonna go back to the previous problem so you can take a screenshot. And let me know when you're done so we can move on. Okay, I'm just gonna assume we're good. And hopefully we're done here as well. Let's go on to number 8 in the test review. So I want to simplify this stuff down for number 8. So the first thing I would do, I have a real number of 192. I would find the prime factorization of this. In this case, it's 2 to the 6th times 3. And then I have a to the 61 and b to the 15. So I want to reduce this. So I have the 4th root here, and I have 2 to the 6th. So what this becomes is I can take out one group of 4 out of these 6 2s. I can't take out any 3s here. I have 61 A's, so I can take out 15 groups of 4 A's. And out of these 15 B's, I can take out 3 groups of B's. And Now I'm going to determine how many do I have left over. Jason, go ahead.
Hold on. Where did you get the 3 from?
So 192,
Uh-huh.
the prime factorization of that is 2 to the 6 times 3. So you have what? 2, 4, 8,
Oh, okay.
64. Yeah, so 64 times 3 is 192. So that's what you get. 64 times 3. That's the prime factorization of it.
Okay, thank you.
No problem. Tanish, go ahead.
So if 192 can be written as 2 to the 6th times 3,
Yeah.
wouldn't that mean on the outside you have a 4, not 2?
What do you mean by that?
Like, wouldn't the outside have 2 to the 2, not 2 to the 1?
No, it'll be 2 to the 1 because I have 2 to the 6 over 4, right? Because it's the 4th root.
Yeah.
So that reduces to 2 to the 3 over 2, or 2 times 2 to the 1 half. The way I think about it is I have 6 2's inside the root, right?
Yeah.
The root is telling you how many groups of that can you make that you can pull out. Out of 6 2's, I can make one group of 4, and I can pull out that group of 4. So that's why I have 2 to the 1. Out of 6 different A's, I can make 15 groups of A's, so I can pull out 15, and then I have 1 A left over.
Okay, yeah, you're right. Sorry.
2 left over here inside though. And then I also have the 3 I forgot. All right. So I have 2 2's left over, so I have 2 squared. I have that 3 I couldn't do anything with. I have 1 A left over, and I have, what's that, 4, 12, 3 B's left over. So I guess you can just rewrite it a little nicer. So you have 2A to the 15, B to the 3rd, the 4th root of 4 times 3, which is 12, AB cubed. But I started with an even root, right? I had an even root of 4, and I had some even, even exponents. So I need to see, well, did it even go from even exponents to odd ones? And if I look at this, well, the real numbers I don't really care for because I know the value of a real number. So I don't need to put absolute value, like let's say 2, because the absolute value of 2 is just going to be 2. So there's no need for that. But I'm going to look at the variables. For A, I start with an odd one, so I don't need to worry about any absolute values around the A. And then for the B, I started with an odd value B as well. So I don't need to really worry about any absolute values for that one as well. So what I end up dealing with, or what I end up getting, is just this answer right here, 2A to the 15 times B to the 3rd times the 4th root of 12AB cubed, which is C. Right? Let me double check that. Yeah. So always double check that you don't need to put any absolute values in. In this case, we didn't need to put anything in because we started with odd exponents, so there's no need. Any questions here? Are we good? Tanish, go ahead. Oh, Liliana, I'll be right with you after that.
Didn't you start off with 2 to the 6th, which is even?
It is, but what's the absolute value of 2?
2.
So there's no point to put them. When it comes to real numbers, you have real numbers, you don't ever want to put absolute values because you can always play with it to get the actual value. Because even if we had like a negative 2 to the 6th power, so we have negative 2, you put absolute values of negative 2, and you just change it in the problem to 2. Because it's a real number, you can always fix fix absolute value to get rid of it, to make it a little simpler.
Okay, so you only put it for variables?
No, you put them for both. But the difference is with real numbers, when you put the absolute values, you can fix it to get rid of them. Like I think the last problem, on the quiz, the last problem on the first page, you have to put absolute values there. But when you put them, you can fix it to get rid of the absolute value. So you would still put them, but you have to fix it to get rid of them. Does that make sense?
Kind of.
Well, like on the quiz, we had something like, let's say we had something like 12 minus, I don't know, 3 roots. It's 144. It's pretty small.
Well, I can tell you the problem. I have the quiz right next.
Okay. Sorry?
I can tell you the problem.
No, I don't want to do quick problems. But let's say you you have something like, you end up with something like this because you go from even root to an odd one. So you have, say, something like this, right? Well, I
Yeah.
can fix this by just taking out a negative here and saying, what's the absolute value of negative of 3 root 3 minus 6? Because 3 root 3 is, no, it's not smaller. We'll make this 2, just make it easier so I don't keep messing up. All right, in this case, 2 is smaller than 3 root 3. So 2 minus 3 root 3, that's a negative number. So you can factor out a negative to put it in this order. And then from here, 3 root 3 minus 2, that's a positive number. So you can rewrite this as 3 root 3 minus 2 cubed. And that's how you do that problem on the quiz. Because it was a real number minus another real number, you have to determine which one's bigger between the two. And on the quiz, it ended up being that the second number is bigger. So you have to fix it by factoring out a negative and rewriting it here. And then when you take the absolute value of this -1, it just goes away. And you're just left with 3 root 3 minus 2 cubed. So they still get absolute values. It's just they get to fix it to get rid of it.
Okay, got it. Thank you.
Liliana, I think you had a question as well.
I did. How'd you get b cubed inside the radical, but also outside of it?
All right, so for that, let me erase some stuff first. So I have b to the 15 underneath the 4th root, right?
Yes.
So let's say I have the 4th root of b to the 15. Well, how many groups of 4 can I make out of 15 b's?
3.
How many are left over?
Oh, I just can't do basic arithmetic.
It's okay, I can't either. Make sense though?
Yes.
Perfect.
Thank you.
All right, number 10 on the test review. So for this one, I have the square root of 33 minus 20 root 2. So this is in one of those weird forms where I can take this 33 and break it up into 2 numbers to make it into a perfect square trinomial. Sorry, Shaylee should double check. We always put the roots, then whole numbers in parentheses, right? I'm sorry, what do you mean by that, Shaylee? Always put roots, then whole numbers in parentheses. Yeah, I'm not understanding your question, Shaylee. If you can retype it just to kind of clarify what you mean, and we can go back and we can talk about that, all right? All right, so back to number 10, I want to fix this problem right here. So 33, I want to break this up into a perfect square plus another number that ends with the root 2 when you take the square root of it. So I'm going to start this by listing out all the square root or the perfect squares less than 33. So I have 1, 4, 9, 16, 25, and then it's 36, but that's bigger than 33, so I don't have to worry about that. All right, so now I'm going to see what do I add with these perfect squares to get that 33. In this case, it's 32, that's 29, 24, 17, and 8. And then I want to figure out, well, when I take the square root of the second number, does it end with a root 2? The square root of 32, that's 4 root 2. So this could work. The square root of 29, that's just the square root of 29. 29 is prime, it's not going to do anything, so that's not going to work. The square root of 24, that's 2 root 6. That does not end with a root 2, so that's not going to work. Square root of 17, that's prime, it's not going to reduce, it stays root 17, so we're not going to use that one either. And then for the square root of 8, that becomes 2 root 2, and that could work. So I have 2 possible solutions, 1 and 32 and 25 and 8. So what I'm going to do is break them up into both these scenarios and see which one gives me the 2AB value that I want of 20 root 2. So for the first case, I'm going to rewrite this. So we say 1 plus 32. For this first case, I'm going to break this into the square root. Oh, sorry, give me a quick second. Never mind, you got it. Perfect. Give me a quick second. Okay, sorry about that. So of 1 and 32, I'm gonna break this up into 2 different cases. So I always put the bigger number first. So I'm gonna put 32 first. minus this 20 root 2 plus the second number of 1. And then from here, I know that my a squared term, that's 32. My b squared term, that's 1. So a is the square root of 32, which we saw is 4 root 2. B is going to be 1. So 2ab will be 2 times 4 root 2, which is 8 root 2 times 1, and that's 8 root 2. This 8 root 2 is not the same as 20 root 2, so that tells me that 1 and 32 is not the scenario that's going to work. But now I'm going to double check this other one of 25 plus 8. So when I double check this, put the bigger one first, we put 25 first, minus 20 root 2 plus 8. So a squared, that's 25. B squared, that's going to be 8. So then a is 5. B is a square root of 8, which we saw is 2 root 2. So 2ab, that's going to be 2 multiplied by my a value of 5, which is 10. So I have 10 times 2 root 2, that's 20 root 2. And that's exactly what I have right here. So that tells me that this is the right one that works, and this is what I'm going to use. It's an ugly star. Any questions about that? Are we good with that? All right. So I know the correct one is now going to be 25 minus 20 root 2 plus 8. And since this is now that I've verified that it is a perfect square trinomial of a squared minus 2ab plus b squared, I know that what's underneath the square root is going to factor out into 5 minus 2 root 2 all squared. And that's because it's going to be in the form a minus b squared, where I saw a is 5 and b is 2 root 2. But I don't need a square root of a square because they just cancel out. So what I'm left with is 5 minus 2 root 2. And we're going to double check because I did go from an even root to an odd one of 1. I need to make sure, well, do I need to fix this? So I need to see which one's bigger, 5 or 2 root 2. Well, 5 is the same thing as a square root of 25. 2 root 2 is the same thing as a square root of 8. And the square root of 25 is bigger than the square root of 8. So I don't need to fix this, and that's going to stay my final answer. Any questions about that?
I have a question.
Yes.
How do you know when you need to execute it like this with the perfect square trinomial?
Anytime you see something ugly like in this form right here, you're like a square root of some number minus some other number times a square root, something ugly like that. It looks like in this exact form, that's when you know to do it.
Thank you.
No problem. Also, Liliana, next time just use the raise hand emoji, I'll call you, just so you don't have to,
Oh, okay, thank you.
Is this meeting being posted later? Yes, I plan on posting this. It'll hopefully be up around 5 or 6, I'm hoping. Slow down. Okay, sorry if I'm going too fast. I'll try to go a little slower. Any questions here, though? Are you ready to move on? Okay, we'll move on. We'll just keep on going, I guess. All right, number 12. So this is what I was talking about earlier when I said we were talking about conjugates. I think in the first problem of the review, I have 3 all over 2 minus the cube root of 3, and I want to get rid of this cubic on the bottom. So multiplying by just 2 plus the cube root of 3, that's not going to work because 2 minus cube root of 3 times 2 plus cube root of 3, that is a difference of squares, but what you end up getting is 4 minus the cube root of 3 squared. And that still leaves you with a cubic on the bottom of 4 minus the cube root of 9. You didn't get rid of it. So this method is not going to work because of that. But we can kind of still use that same logic of trying to change the bottom into the form of a squared minus b squared to get rid of that cubic. But in this case, what I want is, instead of a squared minus b squared, I want a cubed minus b cubed. So what I'm trying to say is, if I can figure out something to multiply 2 minus the cube root of 3 with, I'll put it in the form of a cubed minus b cubed, then I can multiply top and bottom with that, and then I can get rid of that cubic on the bottom. So remember, a cubed minus b cubed, a cubed minus b cubed, that's the factored form, or that's the difference of cubes, which becomes a minus b times a squared plus ab plus b squared. I think I saw someone with their hand up. Are we okay? Good. All right. So what this tells me is that if this 2 minus root 3 is in the form of a minus b, I can multiply it in the form a squared plus ab plus b squared, and that'll get rid of that cubic on the bottom. So in this case, a squared is 4, plus ab will be 2 times root 3, so 2 cube root of 3, and b squared is the cube root of 9. So this right here is what I'm going to multiply top and bottom with this problem to get rid of that cubic on the bottom. So I have, is it 3, I think 3, right? 3 all over 2 minus cube root of 3. And I can multiply top and bottom by that 4 plus 2 cube root of 3 plus cube root of 9 on top and bottom to get rid of that cubic. Are we okay up to here? Do we get why we're multiplying it with 4 plus 2 cube root of 3 times plus cube root of 9? Harshita, go ahead.
Are we just plugging in the a's and b's into a squared plus ab plus b squared?
Yeah, that's pretty much what you're doing. But you
Okay.
need to be careful on what's happening here. Because if I give you something like, because let's say instead I gave you something like 3 all over 2 plus cube root of 3, you have to multiply it with a squared minus ab plus b squared on top and bottom.
Mm-hmm.
So just be careful.
So we don't do the a minus b times it. We don't do that part, right?
Like we don't multiply this with 2 minus cube root of 3. Is that what you're saying?
Yeah.
Yeah, you wouldn't do that, because if you did, it is a difference of squares, right?
Mm-hmm.
And that's fine. But like I showed here, this difference of squares becomes a squared minus b squared, right? So 2
Mhm.
squared is 4, and the cube root of 3 squared is the cube root of 9. And the cube root of 9 doesn't reduce.
Okay.
So that's
Okay.
why that method of conjugate doesn't work. It's going to be, if you find the rest of the factoring pattern that puts it in the form a cubed minus b cubed, get rid of it.
All right. Thank you.
Jason, go ahead.
I have a question. So, like, you said you can't multiply with the conjugate because it'll get us the 3 square root. It's 3 square root 3 squared, right?
You don't multiply the conjugate because it'll give you this part right here. What you end up getting, because if we multiply the conjugate right here, well, it's not really the conjugate, but we multiply right here, right? By putting through a difference of squares, you get in the form of 4 minus cube root of 3 squared, or 4 minus cube root of 9. You never really got rid of that cubic. So that's why it didn't really work.
Okay, but what if we instead because it's a cubic, right? So what if we did 3 squared with the conjugate? Wouldn't that make it possible?
That's a good question. That's actually a really good point. But it wouldn't work. I'll show you really quickly why it wouldn't. Because when you multiply with the conjugate, what you're doing is you're creating a difference of squares, right?
Mm-hmm.
You're saying, why don't I do 2 plus the cube root of 9, right? Which is 3 squared.
Yeah.
Right? Well, on the bottom, it's no longer a difference of squares. So you have to distribute this whole thing out, and you end up with 2 different radicals now. So you're actually worse off than you began. You distribute this 2, you get 4 plus 2 cube root of 9. Distribute this negative cube root of 3, you get minus 2 cube root of 3. And then the negative cube root of 3 times the cube root of 9, this would cancel each other out to leave you with just a positive 3. but now we have 2 roots to get rid of. So you're actually worse off if you did that. Does that make sense?
Yeah. Thank you.
Yeah, so that's why you want. That's a good way to think, but it wouldn't work because you're not creating a difference of squares. All right. So let's go ahead and finish up this problem now. So I'm gonna multiply the whole top by 3. I'm gonna do it down below here. What you get is 3 times 4, which is 12. 3 times 2 cube root of 3, which is a 6 cube root of 3. And then 3 times the cube root of 9 is a positive 3 cube root of 9. And then on the bottom, I already know that this is a factoring pattern of a cubed minus b cubed. I know this will give me, put it in the form of a cubed minus b cubed, where this is a and that's b. So all I need to do is cube it. So 2 cubed is 8, and b cubed is 3. So what I get is 12 plus 6 cube root of 3 plus 3 cube root of 9 all over 5. And that's my final answer. Everyone okay with that? How many questions are you going to go over today? I might have to leave a little early. I'm going over 13 problems, but this video will be posted online on YouTube, and maybe I'll post the work too. Yeah, I'll go ahead and post. I'll probably try to save this as a PDF so I can post this as well. All right, any questions here? Are we okay? I'll leave this up for a bit for you guys to screenshot if you need to. Ajay, go ahead.
So you know how in this question it's a minus b, like 2 minus cube root of 3?
Yeah.
What if it was 2 plus cube root of 3, but do you multiply it by a squared minus ab plus b squared?
Exactly. Like, see down here, I actually did that scenario. You're right. You would multiply by a squared minus ab plus b squared.
Okay. Right.
And then this, yep. And then what you get down here below is that it becomes a sum of cubes, so it becomes a cubed plus b cubed on the bottom.
Okay.
Make sense?
Yep. All right. Thank you.
Perfect. No problem. All right. Let's keep going. Number 13 on the test review.
Can you go back for a second? I need to take a photo of it. Thank you.
Right, no problem. All right, number 13. I actually don't want to do this problem. I'm looking at it again. I think number 15 might be a little better, actually. Just because this works out to only go 1. Yeah, we're not going to do this problem. Instead, the ones you're skipping over here, would they be on the test at number 11, which I don't know if we have done in class before. I don't want to say it will or won't be on the test. I'm not really allowed to say that. But what I do in my Zoom reviews is I choose the problems I think are best to focus on for the test. So I won't say it will be or won't be, but if you understand everything I'm doing on the test review, I think you're in a very good place for the test tomorrow. Make sense, Malachi? I'm sorry, I don't know if I'm saying that right. Great. All right. You know, we'll go over. No, we're gonna skip number 13. I'll do another problem similar to this one at the end off the homework when I find a problem similar to it. But I don't think this is really a good problem to do. So we're gonna skip this one. And we'll go on to number 14. So number 14, I have 2 times the square root of t equals the cube root of t. So what I want to do is get rid of the square root, and get rid of this cube. So I can do that by first squaring both sides, because I'll get rid of the square root. And when I do, I can distribute the square to get 4 times t, and that'll equal the cube root of t squared. And then I can raise both sides to the 3rd power, because when I do, it gets rid of this cubic. These will cancel out. Distribute this 3 again. 4 to the 3rd power is 64 times t cubed, and that'll equal t squared. And then from here, I can divide both sides by, say, t squared. And I'll get 64t equals 1. Divide by 64 to get t equals 1 over 64. And I can take this t and I'm going to check it, because you always need to check your variables. So when t equals 1 over 64, if I plug it back into the original, I have 2 times the square root of t, which is 1 over 64. And remember, it's always best to put your variables as your real numbers as the prime factorization. And 64 is 4 cubed, which is the same as 2 to the 6th. And this should equal the cube root of t, which is 1 over t to the 6th. So this is the same as saying 2 raised to the square root of 1 all over the square root of 2 to the 6th. And that's equal to the cube root of 1 all over the cube root of 2 to the 6th. That's a 2 to the 6th, not a 26. So 2 to the 6th. So we have 2 times the square root of 1 is 1. The square root of 2 cubed will be 2 to the 3rd, which is just 8. And over here, we have 1 all over the cube root of 2 to the 6 is 2 squared, which is 4. 2 times 1/8 is 1/4, and that equals 1/4, and they both equal each other. So that means they are, or t equals 1 over 64 is a solution. Any questions about that? Jason, go ahead.
Wait, I'm sorry. I forgot. How did you get 1/8 and 1/4?
Oh, so I took the square root of 1 and the square root of 26. So the square root.
That's not the square root of 26, though. That's the square root of 2 to the power 6.
Yeah, 2 to the power 6. Sorry, my handwriting just bad. But yeah, it is 2 to the 6th.
Mm-hmm.
So the square root of 2 to the 6th, the square root is the power of 2. So we're basically saying, well, how many groups of 2 can I make out of 6 2s? Well, that's going to be, 3 of them. And that's going to be 8. And that's where you get the 8 from.
Oh, okay.
Same thing
And then
here.
you
How
do
many
the
groups
same
of 3 can I
square.
make? Yeah, it's 2 squared, which is 4.
Thank you.
No problem. Tanish, go ahead.
What'd you do for the second step? Yeah, I didn't really understand.
This part?
Yeah.
Well, I want to get rid of both these roots. So the first thing I did was I squared both sides. And when you square both sides, to the square root of t, the square of that gives you 4t squared, or 4t, sorry. And then here gives you the 6 root of t squared. And then I raised both sides to the power of 3 to get rid of the cube root. So 4 to the 3rd power is 64, t to the 3rd power is t cubed. And then the cube root of t squared, the cube and the cube root cancel out to give you t squared.
Oh, okay. Thank you.
Make sense?
Yeah, thank you.
For the substituting, could you just take the square root and cube root of 1 over 64 to get 2 to 1/8 equals 1/4? Yeah, it's the same thing. Malachi, you're 100% right. You could do it that way. I like to stay consistent when I'm teaching. I always say put real numbers into this prime factorization. So I'm going to stick with doing it that way so y'all can see exactly what I'm doing. But yeah, you could do it that way because you get the same exact thing. Ipek, go ahead.
How did you get 7 over there at the top?
7. Oh, no, that's a 3. So it's a cross out 3.
Oh, okay.
That's my fault. So it's a 3. But I was saying you cross this out with the cube root to cancel out. That's what I was saying.
Oh, okay. That makes more sense. Thank you.
No problem. Any other questions? Are we okay? All right, let's keep going. I'll put this in by accident. Now we're on to the homework. So I'm number 8 on the homework, so I'll give you all a quick second to pull up the homework. Because we're going to be doing homework problems now. All right, so here w raised to the tr to the -1. The problem here is that I don't want a negative here. So I can rewrite this as WT to the, instead of R to the -1, I can rewrite it as 1 over R, which is the same as saying W to the T over R. Because remember, you want to deal with the exponents inside of the exponent first before you deal with the whole thing. So R to the -1, well, that's just 1 over R. T times 1 over R is just T over R. So I can rewrite this as the R root of W raised to the T power. Are you okay with that? All right, let's keep going. Now we're on 47. So for 47, I have the 4th root of 4 times the 3rd root of 3, all over the 6th root of 6. So like I was saying before, always put everything into its prime factorization. It just makes it a little easier to deal with. So the 4th root of 4 is, well, the prime factorization of 4, sorry, is 2 times 2. The prime factorization of 3 is just going to be 3. And the prime factorization of 6 is 2 times 3. So if I put it in exponent form, I get 2 to the 1/4 times 2 to the 1/4 times 3 to the 1/3, all over T to the 1/6 times 3 to the 1/6. So if I look at this here, everything's in bases of 2s and 3s, right? So what I did, can you go back? Yeah, once I'm done with this problem, I'll go back. All right, so what I did here is I broke up everything into its prime factorization, or put it as simple as possible. And what I ended up getting is that everything is in bases of 2 and bases of 3. So I can start combining these. So on the top, I have 2 to the 1/4 times 2 to the 1/4. Well, that's just 2 to the 2 over 4, or 2 to the 1/2. Then I have 3 to the 1/3 and 3 to the 1/6. That's just 3 to the 2 over 6, because that's the same as 1/3, minus 1 over 6, and that's all over 2 to the 1/6. So these 3's, they'll cancel out to give me 3 to the 1/6. And then this 2, well, I can rewrite this 2 to the 1/2 and 2 to the 1/6 as 2 to the 3 over 6, because 1/2 is the same as 3/6. And I can subtract from it this 1/6 I had on the bottom. And what you end up getting is 2 to the 2 over 6 times 3 to the 1/6. Everyone with me so far? All right. And from here, what you want to do is, I don't want to reduce this 2 over 6, because if I did, and I'll show you what happens if you do, we get, I'll put it in red so you know not to do it. We get 2 to the 1/6, or sorry, 2 to the 1/3 times 3 to the 1/6. And when we put it back in radical form, because that's what I want it in radical form, we have the 3rd root of 2 times the 6th root of 3. And while this is not fully wrong, it's not a wrong answer. We don't want 2 radicals as a final answer. You're gonna get points taken off for it, and it's not really like the proper way to write it. You don't want 2 radicals. This is not what you want. Instead, I want to make sure that both denominators and exponents are the same, because when they are, I can rewrite this as 2 squared times 3 to the 1st power, all raised to the 1/6. What you're essentially doing is taking this denominator and factoring it out. So I have 2 to the 2 squared times 3 to the 1st to the 1/6 power. So what you get is that 2 squared is 4 times 3 is 12 to the 1/6, or just the 6th root of 12. And this is a lot simpler than what you have right here. So that's why you want to leave the denominators of the exponents to be the same, so you can only have 1 radical rather than having 2 radicals. Any questions here? All right, I'll give you all a bit to screenshot this if you need to. And then we'll go back one problem if someone wants to screenshot that problem, which is totally fine. All right, so let's go ahead and go to the previous one right here. Is this one you're talking about, Shaylee, you want to see? Perfect. All right. Let's keep going. So now we're on 68. So I think a lot of y'all have problems with this problem on the quiz, so I wanted to go over it. So we're distributing this stuff. So I have root 2 plus cube root of 2 times 1 plus the cube root of 4. So you're going to treat this just like any other multiplication problem. We're going to distribute it out. Distribute the root 2 to get root 2 times 1 is root 2 plus root 2 times the cube root of 4. Then we can distribute the cube root of 2 as well. If you get the cube root of 2 plus 1 is just the cube root of 2. Then the cube root of 2 times the cube root of 4, that gives me the cube root of 8. So distribute it out, and since these roots are the exact same, I can just multiply what's underneath the roots. So 2 times 4 is 8. So from here, I'm going to add like terms. So I have the square root of 2, and then here, I want to combine these radicals, because remember, you don't want one term having multiple radicals. You want to combine them if you can. So I can rewrite this as, or this part right here, I can rewrite that as 2 to the 1/2 multiplied with 4 to the 1/3. And then plus the rest. I can't really do anything with those right now. And the cube root of 8 is 2, actually. All right. And then from here, this part in green, I want the denominators of the exponents to be the same, so I can factor it out. So I have root 2, and I can change this 2 to the 1/2 to 2 to the 3/6. And this 4 to the 1/3, I can change it to 4 to the 2/6. And then the rest of it plus cube root of 2 plus 2. And you could change the 4 to 2 squared if you wanted to. It doesn't really matter. But from here, I can factor out a 1/6 to get 2 cubed times 4 squared to the 1/6 power plus the rest of it. So what I get is 2 to the 3rd power, that's 8 times 16, which is, I have no clue what that is. Let's put the calculator. 8 times 16 is 128. So you get root 2 plus the 6th root of 128 plus the cube root of 2 plus 2. And number 68, let me double check, that's the right answer. Shouldn't do anything wrong. Yeah, looks like I did. What did I do wrong? Because 128, 2, 4, 8, 16, 32, 64 is to the 7th power. So we can rewrite this as 2 plus the 6th root of 2 to the 7 plus the cube root of 2 plus 2. So that kind of just goes to show you that you should stick to what I'm saying from the beginning that I should have done and put this 4, your real number, into its prime factorization, because if I put that as 2 squared 2 to the 4th, I would have saw that reduced. So that's another good example of why you should always be doing that. So I can pull out a 2 here, and I'm left with the 6 root of 2 plus the cube root of 2 plus 2. And then from there, I can't do anything else. So yeah, don't do what I did. Always put your real numbers into its prime factorization, because that way you wouldn't mess this up. Because I would have gotten points off on a test for that if I didn't reduce that 6 root of 128. Are you okay with that? Makes sense? Ready to keep going? All right. So we have one problem left here. Then I want to pull up another problem that I skipped from the review because I think it's a better one on the homework to do. So this is on the notes. This is number 5 in the notes. So go ahead and pull out your notes. Sorry, this is a 12.3, problem 5 in the notes. This is one of the word problems. So go ahead and pull that out so we can go over it. All right. So number 5 in the notes, we're going to find the width of a rectangular prism whose length is 5 minus 2 root 3. Its height is 4 plus 2 root 3 inches, and volume is 26 cubic inches. So remember, volume of a rectangular prism is length times height times width. So volume is 26, so I have 26, and that will equal the length, which is 5 minus 2 root 3. Its height, which we're told is 4 plus 2 root 3. And the width, which I don't know what it is. Okay? So I can solve this out. So I have 26 equals 5 times 4 is 20. 5 times 2 root 3 is a positive 10 root 3. Negative 2 root 3 times 8 is negative 8 root 3. And negative 2 root 3 times positive 2 root 3, well, negative 2 times 2, that gives me a negative 4. And then root 3 times root 3 is 3, so we get negative 12. We can add like terms. 26 equals 8 plus 2 root 3. 10 root 3 minus 8 root 3 gives you 2 root 3. 20 minus 12 is 8. And then from here, I can subtract 8 over. And I get, or where did the W go? I forgot about the W. There we go. Don't forget the W. So it's all right there. It's 8 plus 2 root 3W equals 26. Divide both sides by 8 plus 2 root 3 over 8 plus 2 root 3. And what we get is that this W, since these cancel out, is going to equal 26 all over 8 plus 2 root 3. But the problem here is that I don't want any roots on the bottom. So what I can do is I can reduce 26, 8, and 2 to give me 13 over 4 plus root 3. So anytime you can reduce stuff at any point like this, always take advantage of it because it's going to make your life a lot easier if you do. So 26, 8, and 2 are all divisible by 2. So I get 13, 4, and 1, or just root 3. And now I'm going to multiply top and bottom by 4 minus root 3. Because this creates a difference of squares in the bottom or makes it into a squared minus b squared. So what I get on the top, 13 times 4, that's 52, minus 13 root 3. On the bottom, I get 4 times 4, which is 16. Then b squared is root 3 times root 3, so minus 3. So I get 52 minus 13 root 3 over 13. 52, 13, and 13 are all divisible by 13, sorry. So you get 4 minus root 3. And that's your final answer. I didn't want to do the no problem again, but I couldn't find anything else similar to this. So I just went ahead and redid it. But any questions on this problem? Are we okay with that? All right, so I did want to do one more problem. I'm trying to find one similar to it. All right. And it's going to be 102 in the homework. Let's hope it's a nice problem. So the last problem I want to do is back on the homework. And it's going to be 102. All right, so for 102, the square root of 3z minus 3 plus 2 equals the square root of 6z plus 1. So what we're going to do is I want to isolate one of the square roots, and then I'm going to square both sides. So this problem is a little nice. It actually isolated them for me, because sometimes, I think on the notes, we could have given this to you as the square root of 3z minus 3 minus the square root of 6z plus 1 equals negative 2. So, usually on a quiz or test or on the notes, we actually give it to you in this form that I wrote in black, and then you got to solve it out into the form that they give us. So I just want to reiterate the point that what you want to do is isolate one of the square roots by themselves and then work from there. So I don't need that form, but they isolate one of the square roots for me. So I'm going to go ahead and square both sides. So on the left side, it's a perfect square trinomial. So it's in the form a plus b. So I have a squared, or the square root of 3z minus 3 squared, which will just be 3z minus 3. And then it's 2ab. So 2 times will be plus 2 times the square root of 3z minus 3 times 2. So it should be 4 here, sorry. plus 4. And then plus b squared, which will just be 4. And that's all going to equal the square root of 6z plus 1 all squared. The square root and the square just cancel out, and I'm just left with this. And then from here, I'm going to isolate the last square root that I'm left with right here. I'm going to isolate that one and then square it again to get rid of that. So this 3z, I can move it over to the left side to get 6z minus 3z. That's going to be 3z. On the left side, this 4 and negative 3, they combine to give you just a positive 1. And then I can subtract 1 over, and I'm just left with 3z actually. And on the left side, what I'm left with is 4 times the square root of 3z minus 3. And that's where I'm at right now. Everyone with me? All right. So from here, I'm going to square both sides. You could get rid of that 4 if you really wanted to, but there's no real point. The most important thing is to make sure you only have one term of the square root, just nothing added or subtracted to it. So I can square it and distribute the square to both of these. 4 squared is 16. The square root of 3z minus 3 is just 3z minus 3. And that equals 9z squared. Distribute the 16 in, we get 48z minus 48 equals 9z squared. I'll move everything over to the right side, and what I get is 0 equals 9z squared minus 48z minus 48z plus 48. I can reduce this all by 3. And when you do, we get 0 equals 3z squared minus, what's that? 12 is 36. That's 116. Z plus 16. Oh, yeah, we just did that. All right. So from here, what I want are factors of 48 that add up to negative 16. So in this case, that's going to be factors of 48 and negative 16. 3 and 16 obviously won't work.
4 and 12.
4 and 12. Thank you so much. I don't know why mine's not working. Thank you. 4 and 12. Well, negative 4 and negative 12, right? So from here, I have x minus 4, x minus 12. I divide them both by my a value of 3 to see what the factors are going to be. This doesn't reduce, it goes up. So that's one of my factors. So 0 equals 3x minus 4. This reduces to 1 and 4. The other factor is x minus 4. So what I get is that x equals 4 with 3, or it equals 4. Obviously, you'll have to check this by plugging in both these x's back into the original problem right here and see if it works. In this case, they both do work. I'm not going to double check. You're just going to plug it in and just solve it out, make sure they equal each other, but they both do work. And that's how you solve this problem. Any questions about that? Good. Great. That's all the problems I have for the review. I'm going to go ahead and stop the recording. And if y'all have any questions, Harshita, go ahead.
I get everything after like the first 2 steps, but I don't get how you got the first 2 steps.
So
I don't get why you like squared it.
Oh, okay. So what's happening here, I'm going to redo it. Like these 2 steps right here that I'm erasing?
Yeah.
Okay. So what's happening here is that I'm going to square both sides, right? You get that?
Yeah.
So this part right here, what we have right here is a plus b squared, right? An a term plus another b term all squared. And this is going to factor or FOIL out to a squared plus 2ab plus b squared. So a is the square root of 3z minus 3. So a squared, or this term right here squared, is just 3z minus 3. And then 2ab is 2 times your a term times your b term. 2 times 2 is 4. times that is 4 times the square root of 3z minus 3. And then we plus the b squared, or b is 2, so it's plus 4. And then that all equals the square root of 6z plus 1.
Yeah,
Does
I
that
get
make
it now. Yeah, yeah, that makes sense.
Perfect. Go ahead and undo all this. Any other questions? Are we okay? Can you go back to question 48 when given the chance? Can you go over 9294? All right, let me go back to 48 first, and I'm going to end the recording.